the worked example effect and the expertise reversal and element interactivity effect. Considerations for Instructional Design by Leslie Marsh, September 2023. Welcome. My name is Leslie Marsh. I'm an instructional designer at Sinclair Community College. In this microlearning video, we will briefly review cognitive learning theory, identify two instructional design effects, the worked example effect, the expertise reversal and element interactivity effect. I will also illustrate each instructional design effect in a learning scenario for clarity. Cognitive load theory is an educational framework that considers how our brains process and store information. It focuses on optimizing the way material is presented to learners based on our understanding of human cognitive architecture, which is the way that the brain works to process and store new information. The core components of CLT include three memory structures: sensory memory, working memory, and long-term memory, and three mental load conditions: intrinsic, extrinsic, and germane, that interact in the entire process of learning new skills or knowledge. Understanding these concepts allows instructional designers to create effective instructional materials. Sweller, 2020. Applying these 6 concepts of cognitive load theory has important implications for instructional design. Presentations and materials should be designed to be visually and verbally focused only on directly relevant concepts to reduce extraneous load. Sectioning complex subjects into manageable parts and building the learning path from simple to complex helps to manage intrinsic load. Incorporating interactive elements such as problem solving or real-world examples that foster deep thinking and schema formation maximizes germane load. Sweller, 2020. When the 6 basic concepts of cognitive load theory are used as a basis for designing instruction, they can have a demonstrable effect on student success. When students are beginning to grapple with complex new ideas or skills, there are many concepts to consider and coordinate. Balancing and coordinating all of these concepts is called element interactivity and is part of the extraneous load on working memory. Sweller, 2020. Students could be left to learn this by trial and error, or a learning effect called the worked example effect can be applied. In the worked example effect, students who are first learning material are provided with completed examples of problems or scenarios to study. These worked examples provide a model for students to learn from, which lowers the extraneous load of the new concepts and skills on working memory. Rather than the learner figuring out by trial and error how to proceed with solving a problem, the worked example provides them with the exact process to follow. The learner can then apply this pattern to subsequent problems of a similar type. In this case, the worked examples demonstrate diagramming sentences using Reed-Kellogg diagrams. These worked examples provide a roadmap that students can follow to diagram simple sentences and understand how parts of speech work together to form a sentence in English. However, if students are working at a higher level of knowledge, a different effect must be taken into account. This is the expertise reversal effect. College English students are far more likely to already have expertise with sentence structure and are now working on writing research papers, annotated bibliographies, and the like. Diagramming sentences would slow down their acquisition of this style of writing. Instruction in English at a higher level would not include diagramming sentences, but would focus on teaching new skills in language and writing. Understanding the way the human brain processes information and designing it to enhance those processes can ensure success for students at all levels. Thanks for listening. If you have any questions or comments, you can reach me, Leslie Marsh, at leslie.marsh@sinclair.edu.